Hello everybody. So in this video, we're going to look at partial fractions with a repeated linear factor. And I want to start by showing you that when we have an algebraic fraction such as this, where the denominator is squared, this is identical to two fractions where one denominator is a repeated factor of a first denominator. And the reason for this is that if we were to subtract one from the other, so we have 2 over 2x minus 1 squared. If we were to subtract this fraction from this one, well then we need a common denominator. So we need to multiply the left fraction by 2x minus 1. So now we get 2x minus 1 over 2x minus 1 all squared. So this fraction is exactly the same as this one, but written with the denominator that we need, 2x minus 1 all squared. And if we take away from this 2 over 2x minus 1 all squared, then we could subtract this 2 from 2x minus 1, and we get 2x minus 3 all over 2x minus 1 all squared. I hope this shows you that when we have a denominator which is a linear factor squared, the partial fractions involve a linear factor and then a repeated linear factor, okay? And in example 2, we'll look at applying this within this question. So to express this fraction with partial fractions, we need to factorize the denominator. So we'll make this identical to a constant a over our first linear factor, x plus 4, plus a constant b over the first factor, x minus 1, put this in brackets as well, and then the repeated linear factor of x minus 1, so plus c over x minus 1 all squared. And now we need to work out the constants a, b, and c. And to do this, we need to cancel out the denominators. So we'll multiply every term by x plus 4 and x minus 1 all squared. So you can see that these two will cancel, these will cancel, this x plus 4 will cancel with this one, this x minus 1 will cancel with one of these, so this becomes x minus 1 to the power of 1, and this x minus 1 squared will cancel with this x minus 1 squared. So now we get x squared minus 6x plus 10 on the left hand side, and this is identical to a lots of x minus 1 squared plus b, and then we have the x plus 4 and then x minus 1. So we'll have b lots of x plus 4 times x minus 1 plus c times x plus 4. And now to work out c, we can make x equal 1, and then this will become 0, and this will become 0. So we eliminate the a and the b terms. So if we say let x equal 1, then the left hand side becomes 1 take away 6 plus 10. So 5 is equal to, the a is cancelled, the b is cancelled, and then we've got 1 add 4, so 5c. So therefore, c must equal 1. And now we can work out the value of a by letting x equal negative 4. So this will cancel out the b's and the c. So if we say let x equal negative 4, we have negative 4 squared minus 6 lots of negative 4 plus 10. So this becomes 50 is equal to, and then we have negative 4 minus 1, so minus 5, and minus 5 squared is 25a. So therefore, a must equal 2. So now we've worked out a and we've worked out c, we need to work out b. And what I like to do here is to work out b by equating the coefficients of the x squared term. So we know on the left hand side the coefficient of the x squared term is 1. So we know 1x squared will be equal to, and on the right hand side we have this x minus 1 all squared, so this will give us an x squared term, which will times by a, so this will give us ax squared. Similarly here, this will have an x squared term, which will times by b, so plus bx squared. And we can cancel out the x squared terms, so these will go, and we know that a is equal to 2. So we have 1 is equal to 2 plus b. So therefore, b must equal minus 1. And now we can substitute these values of a, b, and c back into here, and we get 2 over x plus 4 minus 1 over x minus 1 plus 1 over x plus 1 all squared. Okay? So let's move on to question 3. Okay, so for example 3, we've been asked to express this fraction in partial fraction form. So the first thing we need to do is to factorize out this denominator. So we can write this fraction as 6x squared minus 13x plus 15. And when we factorize this denominator, we'll take out the x squared from both. So we're left with 2x minus 3. So this will be identical to a constant a over the x term plus a constant b over the repeated linear factor, so x squared, plus a constant c over 2x minus 3. We'll cancel out the denominators by multiplying both sides by x squared times 2x minus 3. And you can see these will cancel. This x will cancel with one of these x squareds will cancel with this, and this 2x minus 3 will cancel with this one. So now we get 6x squared minus 13x plus 15 is identical to a lots of x times 2x minus 3 plus b lots of 2x minus 3 plus c lots of x squared. Okay? If we let x equal 0, we'll cancel out this term and we'll cancel out the c term. So we'll say let x equal 0. The left hand side will become 0 minus 0 plus 15. So 15 will be identical to this is gone, this is gone. And when b equals 0, we get minus 3. So minus 3b. So minus 3b. So therefore, b must equal negative 5. And when we let x equal 1.5 or 3 over 2, that will make this term equal 0. So now we can work out the constant c. And when you put 1.5 in the left hand side for x, we get 9. So 9 will be identical to 1.5 squared c, which we'll write as 9c over 4. So therefore c must equal 4. And then to work out a, again we'll equate coefficients. I'm going to equate the x squared term. So for our left hand side, we get 6x squared is equal to, we have 2x squared here, we'll times this by a, so 2a x squared, and then we get another x squared term here, cx squared. We'll cancel out the x squared terms, and we know that c is equal to 4, so we've got 6 is equal to 2a plus 4, so a must equal 1. So in partial fraction form, we've got 1 over x minus 5 over x squared plus 4 over 2x minus 3. So thank you very much for watching, and I hope you found that helpful. If you did find that helpful, please like and subscribe. And you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again and take care.